Oh, hi there. Thanks so much for showing up for your learning. It's Jennings, and we are looking at, oh yeah, I started this already. I need to reopen it. So you're gonna see my desktop here. It's very, very embarrassing. Okay, here we go. All right, reopened. So we are looking at the exponential section of our practice quiz. And this exponential section, oh man, it's a good section. It's got some of the most valuable skills that we're gonna look at in math. And this is how I want you to use this video. Okay? You're going to come here after you've gotten stuck with some type of problem. You're going to come here to check your answers. You're going to come here to confirm whether you've got the skills or whether you have a question you need to come ask me or ask your favorite math teacher and really figure things out before the test. All right, so the first thing that we're looking at is this skill of expanded form. So this is a very useful skill to be able to say, okay, k to the 5 is the same thing as 5 copies of k multiplying. So, okay, I would write that this way, k times k times k times k times k, done. All right, but if I have something that looks like that, 2x raised to the power 3 is actually a little bit different, where the base is actually 2x, so the base has got more stuff going on. So this would be 2x multiplied by 2x multiplied by 2x. 3 copies of 2x multiplying. Done. We can also work backwards to write things that are expanded in exponential form. So I count these as 1, 2, 3, 4, 5, 6 copies of m, so that's m to the 6. Over here I can count 2 copies of p, so that's p squared, and then 1, 2, 3, 4 copies of y, so p squared y to the 4. That's that. Next, we've been asked to evaluate some exponents. That is to say, 7 to the 3, what is that? Well, it's 7 times 7 times 7. I can write it out in expanded form and multiply those. 49 times 7 is 343. Okay, circle that final answer. This here is, if I expand it, negative 4 times 4 times 4 times 4. 4 is the base of this exponent, and we happen to be subtracting that thing. So it will end up being negative at the end of the day. That's negative 256. But over here, we have negative 6 squared, and that is going to actually be negative 6 times negative 6. Negative 6 is the base in this case, so that's like negative times a negative gives me positive. So that's a 36, final answer. Give me one moment, folks. Let's see if my tools are working. And we're back. So here we go. Yes, so we talked about why that's 36. Let's go. If we have 2/3 all cubed, well, we can use expanded form if we get confused about how to do that, can't we? Yes, Jennings loves it when we use expanded form when we're confused. He never answers our questions, just tells us expanded form shows the way. This is 2 to the 3 divided by 3 to the 3, because of course this is just 3 fractions in a row multiplying. And 2 to the 3 happens to be 8, and 3 to the 3 happens to be 27, and I happen to like to circle my final answer, so there you go. All right, now we've been asked to simplify these using exponent rules, and that's really great. But remember, you can use expanded form when you get confused. And this is 4 copies of x multiplying 7 copies of x. So in total, that's x to the 4 plus 7. It's a total of 11 copies of x multiplying. But here you've got 4 copies of v multiplying themselves 9 times. It's like 9 groups of 4. I seem to remember in grade, I don't want to say that. In grade way before 9, we talked about 4 groups of 9 as the number 36. So this is v to the 36. Okay, 7 copies of a being divided by 3 copies of a. Well, I seem to remember that those cancel. So this is a to the 7 minus 3. We're going to take away that many copies of a from the multiplication on top to give us a to the 4. Again, when you get confused with these, use expanded form to relearn these things. Oh, here's a multi-stepper. Okay, so this one, I'm going to do the stuff in the brackets first, not because I have to, but because I want to. That's going to be b to the 10 divided by b to the 3, all being raised to the power 3. Well, b to the 10 divided by b to the 3 is b to the 7, because I subtract exponents in that case, all being raised to the power 3. There I multiply exponents, this is b to the 21. Circle it as final answer. Can't be simplified more than b to the 21. Okay, x to the negative 4 times x to the negative 3. Oh, well, that's the same thing as add the exponents, x to the minus 7. And I seem to remember Mr. Jennings talking about negative exponents like bossy landlords. So that's x to the 7 on the bottom. Downstairs. It moved. It took all its stuff. Okay, over here. 14 divided by 7. Okay, that you just do. You don't invent new rules for division just because you learned about exponents. You keep on using the old rules. They're still true. Okay, and so 14 divided by 7 is 2 every day of the week, unless we invent new systems of arithmetic, with mathematicians sometimes do. But we don't do it to confuse grade 9 students on purpose. Okay, so we didn't do that to you here, so don't be confused. Okay, x to the 2 divided by x to the 5 is x to the 3, but downstairs. And y to the 15 divided by y to the 7 is y to the 15 minus 7, which is still 2 multiplied by y to the 8 divided by x to the 3. And if you're wondering, how did Jennings get that x to the 3 downstairs? He really went over that really fast, didn't he? Well, here, let me highlight it. My highlighter is so fat. Okay, this bit here. Okay, I'm going to use expanded form and show you. X multiplied by x is x squared over x times x times x times x times x. Cancel, cancel. There's 3 x's downstairs. That's the x to the 3. Okay. See how useful expanded form is? It shows the way. It shows the way to your laws of power. Here we are multiplying two powers. They have similar bases. I mean, there's similar bases in there. 3 times 2 is 6. It's not 5. We don't invent new rules of multiplication. X to the 1 multiplied by x to the 3 is x to the 3 plus 1. That's x to the 4. And y to the 2 times y to the 5 is y to the 7. Done. Final answer. Circle your final answers. I like that. Okay. This one. Oh, man, there's so much going on. C to the 3, H to the 9, Y to the 15 being divided by 1/2 G to the 2, J to the 8, Y to the 7. But it's all raised to the power 0, so it's 1. Okay? Anything raised to the power 0 is 1. So this is a kind of math joke. It's a math joke that grade 9 math teachers love to put on the exponential test. So there you go. And at the risk of explaining the joke, and it not being funny anymore, it's still funny to us, okay, even though I've explained it. All right, so here, I want to write this in scientific notation. So I recognize that there's an invisible decimal place there and a bunch of zeros going, zero repeating there, going on to infinity. All right, I take this decimal and I move it 1, 2, 3, 4, 5, 6, 7 times to put it right there. So that would be 3.5 times 10 to the 7. 10 to the 7 is the same thing as 10 million. This was 35 million. 10 times 3.5 is 35. So I didn't change the number. I just changed how it's written. It's like this is my hand in condensed form. Okay, I use the two for different purposes, but the same basic tool. All right, but what about this if the decimal went the other direction? Well, I go 1, 2, 3, 4, 5, 6. Oh, that's also 7 moves, but it's in the other direction. So I write this as 8.9 times 10 to the negative 7, because the decimal place is going the other direction. So actually you need to take the number 8.9 and divide by 7 copies of 10, not to multiply by 7 copies of 10. Okay. So that is to say, if I write this in standard form, I would say it's 6, 6, 7, and then I'm going to go ahead and count me some 11 moves of the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, put the decimal place there. All right, and it looks like this. Boop. And then put in your zeros. And that would be the number in standard form. You can say that's equal to 6.67 times 10 to the negative 11. Okay, done. I would circle it, but it's so big a number, I would waste ink. All right, and this is 7, 8, and then count 6 moves. Or you can just recognize that this is the number 1 million, so this will be 7,800,000. And then you could check your work with your checking your work pen. 1, 2, 3, 4, 5, 6. That's 6 moves. We were asked for 6 moves, so hooray, circle it, final answer. All right, so now we want to evaluate these things using scientific notation to express our answers, and I've shown you some shortcuts to do these without a calculator, or sometimes like this one, I'm just going to use a calculator. That looks pretty calculatory to me. It's not that bad, but I don't want to do it. Okay, so let's see how I can do it. Anyhow, don't care. All right, let's do this one, the first one. Okay, so this I can rewrite as 2.5 multiplied by 1.8 multiplied by 10 to the 5 multiplied by 10 to the 3. Here we are multiplying by 5 tens and by 3 tens, so that is end of the day 8 tens multiplying, and 2.5 times 1.8 happens to be 4.5. So we have 4.5 times 10 to the 8. We circle it. That's done. Final answer. Next, this one here. Calculator problem if I ever did see one myself. I can do it, but I don't want to, and I don't want to teach you how to do it. So I'm just going to do it on calculator. This one, I would write it as being equal to 6.8 divided by 2.5. How many times is 2.5 going to 6.8? It's a little more than 2, but not that much more. And then here I'm going to be multiplying by 10 to the 3 minus, because I subtract the exponents in this case, minus 4 on the bottom. So that's equal to whatever the result of that is. 6.8 times 2.5 equals 17. I think I did subtract. I did times. There. 6.8 divided by 2.5, because this is divided by 2.72. You see how important it is to have a little guess there? That was very important for me to catch that error before I wrote it down. It was actually a real error. Times 10 to the 7. Done. So none of these questions have like adjusting the power of 10 yet, which is too bad, but this one do. This one sure do. Okay, so this one, this is equal to 2.2 to the 5 times 10 to the 2 times 5. So that's equal to 2.2 to the 5 times 10 to the 10. When raising powers to powers, we multiply the exponents. And now I just need to know what 2.2 to the 5 is, and with a doubled Pascal's triangle I could find out, but I can also find out this way with a calculator. 51.53632. So that's times 10 to the 10, but it's not proper scientific notation yet. I need to scooch that decimal place one spot. So that means I'm going to be adding an extra power of 10 here, so it's going to be 10 to the 11. Circle it, that's done, final answer. Okay, now here we go. All right, we have been asked about Ontario and BC. Ontario's population is 1.6 times 10 to the 7. BC's population is 5.6 times 10 to the 6. And we want to know how many more people live in Ontario? Well, that's question A. Okay, and for question A, I would do 1600000. That is Ontario's population, 16 million. I would subtract BC's population, which is 5,600,000. Probably 98% of that living in Vancouver. And we do the subtraction here. We get 10,400,00. Oh, that is the answer, I believe. But we could give our answer in scientific notation here. So that's 1.04 times 10 to the 7 is the number of people that live in. I should say the number of extra people or something like that. It's a really weird way of saying this sentence. I'm going to write this sentence again. There are 1.04 times 10 to the 7. I have no way of doing that exponent right now in this text editor. More people in Ontario than in BC. Okay? That's how I would say that. Not the way I was saying it up there. That was really weird. My brain was doing things in a strange order, and I want to make sure I get that power 7 in there, so I put it in there. But if I want to know how many times bigger it is, well, that is question B. That's a different question. That would be 1.6 times 10 to the 7 divided by 5.6 times 10 to the 6, which is equal to, well, 1.6 divided by 5.6, we're going to do that. 1.6 divided by 5.6 is equal to this, 0.28. So it's 0.29, we'll say, we'll round to that. 0.29 times 10 to the 1, because we subtract the exponents here, but that's super awkward. We're going to actually multiply by that 10 and say it's 2.9 times bigger. So those are all the skills in the exponential section. If you can do that, then you are on the team for exponents. And those are all the sort of mild, medium level stuff. Any questions? Come visit me at lunch or in class. Bye for now.